talking about OS virtualization. There are other kinds of virtualization being talked at this conference and elsewhere, but we're really focusing in particular on virtualizing boxes, individual boxes, or large sets of boxes potentially in a cluster case. I'm not talking about desktop virtualization, so many of you are probably familiar with VMware's Fusion product for VirtualBox or Parallels that are used typically on your laptop to run different OS instances. In that case, you're running the virtualization software within your operating system instance. What we're talking about here is having a hypervisor layer, which is labeled the virtualization layer here. That's a thin layer that sits just above the hardware. It could be firmware, but it's a thin layer that actually does the virtualization work on that system. So it doesn't necessarily introduce a lot of overhead. We'll talk about that in a minute. And then on top of that, you run a virtual machine. And in the slides that I'm going to show you, you'll typically see this gray box outlining the operating system and the applications. That's the virtual machine instance. One of the things that's not labeled here is that space between the virtualization layer and the virtual machine, the gray virtual machine area, is actually quite important. That's a very clean interface, quite different than let me leave it at that. It's quite a clean interface, and it has some interesting ramifications for how we might actually be able to take advantage of it. Okay, so when you look at the enterprise and you look at how they actually are using virtualization, it's really mostly about consolidation. They have a very large number of machines in their data center, and they're underutilized. And so what virtualization lets them do is shift large numbers of OS instances in virtual machines onto individual pieces of hardware to increase their utilization. So that's not normally the case in HPC, right? We're obviously trying to use as much performance on each box as we possibly can. I will mention as an aside that there are some places in HPC where this consolidation model actually makes sense, especially as we go to larger and larger multi-core and larger socket systems. There are parts of the HPC space, again, very diverse space, that are not able to take advantage of the full parallelism within a single box. And that's going to become more the case as we have more and more cores. So there's going to be some desire, even within the HPC community, to consolidate multiple pieces of workload onto single boxes. But by and large, this is really mostly the focus in the commercial space, and not the primary focus in the HPC space. So this comes back to the earlier point about this clean layer. That clean abstraction layer between, VMware ESX is the name of our virtualization layer. Again, I'm not pitching product here, but the slides I'm using happen to have VMware terminology on some of them. So that's the hypervisor layer. That layer between the VM and the hypervisor layer is actually quite a clean layer. And it easily allows us to do things like snapshotting that VM. And if you're using desktop virtualization, you're very familiar with this idea of being able to snapshot your Windows instance that's running on Linux, stash it away, and then start it up again later. It's that same sort of thing, but in the server environment. It's very commonly used in the enterprise. Another, and perhaps maybe the coolest feature that's supported by virtualization platforms is the ability to live migrate workload from one box to another in the data center. And we're all techies, right? We know it actually does stop. It pauses very briefly, but it's a very dynamic action where the running virtual machine is actually paged over to a second node while it's still running in rounds of transfers, basically, until you get down to a small working set. Then you briefly pause the VM, shift the rest of the bits over, and then continue it. It's a very nice capability, and it adds a dynamic aspect to the data center that wasn't there before. And this is actually one of the capabilities that we'll be able to exploit in quite interesting ways for HPC. Okay, so let me talk about some of the opportunities, ways that we could use some of the virtualization technology to good effect in HPC. Okay, so first and maybe most obvious, and I think that it's probably worth saying that people in the HPC community, probably the first reason that they're even somewhat interested in thinking about virtualization is that they're perhaps interested in taking advantage of the cloud. If you look at all of the cloud infrastructures that have been deployed to date, all the major ones, they're really virtualized infrastructures. So your workload is uploaded into the cloud and it runs within a virtual machine, and then results are brought back. So it's incumbent upon us as a virtual platform provider to look at HPC type workloads and make sure that the base platform capabilities are delivering good performance for technical workloads in addition to enterprise workloads. But clearly this is sort of table stakes for using the cloud, is for your application workloads to be able to run in a cloud environment. And I should also say that there are kind of two pieces here. One is the virtualization itself, and then the other is, as we move HPC into the cloud, I think it's very clear we're going to find that the current cloud instantiations have some deficits that need to be addressed in order to make it more appropriate for HPC in general. And in particular, one of the examples I give is, right now, if you instantiate n nodes in a, say, EC2, there's really no way to talk about locality at all. So you might be trying to instantiate a 100-node cluster, a virtual cluster in the cloud, but there's no way to say, I need those 100 nodes sort of co-located together, maybe want them on the same switch infrastructure, I need them near this storage. That sort of specification of locality is something that is going to have to get looked at. It's one of the things we're looking at actually in our cloud offering, but it's going to be needed in order to make the cloud more appropriate for HPC. That's separate from what I'm talking about. I'm really focused mostly on making sure the base virtualization capabilities are appropriate for HPC. Okay, so let's go through some of the use cases here. So on the left, what we have is sort of your typical compute cluster in an HPC environment, where the administrators have decided, what version of Linux we're going to lay down on the cluster nodes, and that's the decision, right? So if you come along with an application that happens to have been ported and qualified on that infrastructure, then you're fine. But in situations where you're a large supercomputing center and you're trying to support a diverse set of customers, or internal or external customers, then this is a limitation, right? There are some people that want to use SUSE, some want Red Hat, some want Windows, et cetera, et cetera. If you move to a virtualized environment, and instead of deploying a set of operating system instances on the nodes in the cluster, you merely deploy the virtualized infrastructure instead, and the site administrators are now responsible for managing that virtual infrastructure. You can then come along as an end user with your pre-wrapped operating system and application instance with whatever you need optimized in there. You want to use funky library ABC, you can do that. If you need a really old version of Linux or want to run an old version of Windows, it doesn't matter from the perspective of the site administrator. They are agnostic to that because you really made that decision and it's been wrapped within the VM abstraction. So having that ability to support a heterogeneous mix of operating system and application workloads is one of the potential benefits of moving to a virtualized environment.